Name of subject, internal combustion engines. Name of chapter, SI engines fuel supply system, ignition system, combustion. Name of topic, capacitor discharge ignition system. Contents, capacitor discharge ignition system. So dear friends, in the last video we already discussed about the electronic ignition system. So the capacitor discharge ignition system is one of the basic type of electronic ignition system. So the name indicates itself the capacitor. So we know the capacitor is also called as a condenser, which is generally used to boost the voltage. So such kind of a capacitor we are using in the setup of capacitor discharge ignition system. So here we have the diagram or the construction of this capacitor discharge ignition system. So it consisting one rotating magnet which is having the north and south pole. It always rotating in the clockwise direction as the crankshaft will rotate. So there is one exciter coil which is just in front of this particular rotating magnet. Then again there is one diode connection is there which is connected to one ignition stop switch. Again the exciter coil is again connected with one more diode which is connected over here. So this is connected with one more device and this is nothing but called as a capacitor. This connection is again connected with one device and that is called silicon controlled rectifier, that is SCR. This is again reconnected, or we can say it is connected with the resistor, and it is connected with one trigger, and there is one rotating pulse, or we can say there is one pulse rotor. So again in front of just this one the two windings are there. This is the primary winding and here is the secondary winding, and this secondary winding is again connected to the spark plug. So this is something about the construction of this particular capacitor discharge ignition system. So it mainly consists of rotating magnet, ignition switch, charging resistor, tank capacitor, silicon controlled rectifier, SCR triggering device, step-up transformer, spark plug, as we just discussed. A rotating magnet is designed to give or increase the voltage to 250 to 350 volts. So the main aim of this particular magnet to increase the voltage from 250 to 350 volts initially. This high voltage is used to charge the tank capacitor or condenser to this voltage through the charging resistance. So the main intention of this rotating magnet is what? To increase the voltage up to 350 volts, and with the help of this increment in the voltage we can charge the capacitor which is connected over here. Okay, so the charging resistance is also so designed that it controls the required current in the SCR. So SCR is nothing but the silicon controlled rectifier, and which is connected along with this one. Depending upon the engine firing order, whenever the SCR triggering the device sends a pulse, then the current flowing through the primary winding and is stopped, and the magnetic field begins to collapse. This collapsing magnetic field will induce or step up high voltage current in the secondary, which while jumping the spark plug gap produces the spark, and the charge of air fuel mixture is ignited. So what is this? So initially what happened? So the diode which is present over here. So the main function of a diode is one-way connection. Means whenever the current will flow from this direction and then it will be moving forward, that will not revert back. So this is one-way wall kind of a connection which is present over here, and this is called the diode. The similar diode is again present over here. We can use this particular diode for the ignition stop switch kind of a work. And here is that silicon controlled rectifier. So what is the role of silicon controlled rectifier? We'll understand. So initially what happened, as this particular magnet will rotate, the north and south pole will be there, it will rotate in the clockwise direction, and the exciter coil will be there. Because of the magnet rotate, the magnetic field will be generated and the voltage will be induced, and because of the voltage will reach up to 250 to 350 volts. Then because of that high voltage, that voltage will supplied through the diode, and as I told you earlier, the diode is a one-way connection, and because of this the capacitor will get charged. Okay, so capacitor will continuously charge, and again this particular capacitor will get charged continuously because of this particular rotation of the magnet. So one time will come, that time because of the connection of SCR, one time will come, that time this pulse rotor will start to rotate. So as this pulse rotor will start to rotate, and again there is one exciter coil that will work as a trigger, and because of this particular kind of a rotating magnet, this is also one kind of a rotating magnet, and because of this, as this trigger is there, the excitation will be there, excitation in the form of a voltage, and through the resistor that will come in the SCR circuit. So SCR is silicon controlled rectifier. As it once come in the SCR circuit, the small EMF is induced in this circuit itself, and as the amount of voltage supplied from the diode to the capacitor, it will be break, and that thing will again come up or come down inside this SCR, and that small EMF is induced, and again that amount of EMF will supply to this primary winding and the primary windings, and then again it will come to the capacitor, and this circuit will be completing. And after there will be some excitation in the primary winding, again the high voltage will be generated in the secondary winding or the secondary coil, and that high voltage current will then supplied to the spark plug. So this is the simple working of capacitor discharge ignition system. So why it is called the capacitor discharge? So initially we are going to just excite the capacitor, we are going to charge the capacitor. But once the trigger will be there, as the pulse rotate, there will be some EMF is induced inside this particular circuit, and because of that there will be a stoppage of supplying of the current inside the capacitor, and because of the diode it will not revert back. So that time that amount of voltage or the current will supply to the SCR, that is silicon controlled rectifier, and from the SCR then it will be supplied to the primary windings. Okay, so in this case the capacitor will get discharging. Okay, means the capacitor is initially charging, and now as this will rotate, now the capacitor will start discharging, and that amount of voltage will supply to the SCR circuit. So that's why it is called as a discharge ignition system, capacitor discharge ignition. Again, with the help of one video, we'll understand the working principle of this particular capacitor discharge system. So please watch the video with the help of
Hey guys,
this
welcome back to the
video.
channel.
Again,
The evolutions resulted in stupendous
useful.
improvements in the field of technology. They replaced heavy bulk components with compact-sized and precise electronic systems. These electronic components also play a vital role in modern ignition systems for efficient operation. In this video, we are going to discuss such an electronic ignition system in automobiles called the Capacitive Discharge Ignition System. We will be talking about what CDI is, its construction, working, advantages, and disadvantages. First of all, why do we need CDI? The earlier types of ignition systems that we discussed used contact breakers, a mechanical component for opening and closing the circuit. This resulted in wear that would affect performance of the ignition system. The time taken for charging the coils was also longer in the older ignition systems. In order to overcome this, a capacitive discharge ignition system was developed. Capacitive discharge ignition system is an electronic ignition system which uses a capacitor that can store and discharge the charges. Here, the high current from the capacitor discharge is used for charging the coil. The capacitor takes only a fraction of time for charging and discharging, and this makes this system more efficient than the others. A CDI system consists of an excitation unit, a diode, a capacitor, a triggering unit, a silicon-controlled rectifier, an ignition coil, and a spark plug. Now let us discuss these components one by one. The excitation unit consists of a permanent magnet and an exciting coil. The magnet is attached to the flywheel and the coil is wound over a stator. When the magnet rotates, it induces an EMF in the coil. The next one is a capacitor, which is a charge storage device. It is made up of two conductors separated by an insulating material. Then there's a diode. A diode is a semiconductor device which allows the current to flow only in one direction. Then we have a triggering unit consisting of a pulse rotor and a triggering coil. When the magnet in the rotor comes near, coil gets excited. This in turn sends a triggering signal to the silicon-controlled rectifier. The SCR is a current control device which allows the current to pass through it only after it gets triggered. It consists of 3 terminals, out of which one acts as a gate. The SAR will conduct only when a small current is supplied to the gate. Then there is an ignition coil consisting of a primary and secondary coil wound over the iron core. It acts as a transformer which steps up the supplied voltage. Next to this, we have a spark plug. A spark plug consists of a central and a ground electrode. Now, let us see how these components all together make up the CDI system. The excitation coil is connected with the diode and the capacitor in series. One end of the primary winding is connected to the capacitor and the other end is connected with the SER. The SER is in turn connected with the triggering unit and the capacitor. The secondary coil is connected with the spark plug. Now let's see how the system works. When the magnet rotates, an EMF is induced in the exciting coil. Because of the EMF, current flows to the primary coil through the diode and the capacitor. This charges the capacitor. When the magnet rotates, the direction of current changes. Because of this, the capacitor tends to discharge the stored charges, but the diode, which allows current in only one direction, prevents the capacitor from discharging. But when the triggering coil gets excited, a small current passes to the SCR and triggers it. This makes the SCR allow the capacitor to discharge. Thus, a high current will flow through the primary coil and it changes the magnetic field around it. Because of this, a high voltage gets developed in the secondary coil, and the high current due to this is fed to the central electrode of the spark plug. Due to the high potential difference between the electrodes of the spark plug, the gap between them gets ionized, resulting in the formation of spark. This is how the capacitive discharge ignition system works. The capacitor takes a small amount of time to charge and discharge, and high voltage can be induced in such a short time. This is a great advantage of the system when compared with the others. But there is also a possibility of producing electromagnetic noise, and the short duration sparks cannot ignite lean mixtures of fuel. Well, that's it for this video, guys. We'll meet up again in the next one. Until then.
So hope you understood the things in well manner. With the help of the video, we just understood the capacitor discharge systems working. So thank you so much for watching this particular session. Thanks a lot.